Hello everyone, my name is Kyle Davis and welcome to the video. So today we're going to be looking at the capabilities of having R and Power BI, and I've looked at some of the other videos on Power BI and R on YouTube, and sometimes they're missing something or a little bit of context, and what my hope is for this video is to provide sort of an all-in-one encompassing look at how you might import data into R or into Power BI through R, how you might make changes to your data by using R, and then how you can upload graphs that make reasonable sense. And I tried to provide a good example of using some beer data and creating different data sets in R using statistical analysis like a correlation matrix, for example, and how you might be able to port those stats into Power BI utilizing the full range of R tools. So as always, you can look in the description for different timestamps to skip around the video. But I think that this video kind of packaged together will give you a really good introductory glance at all of the capabilities that Power BI has in incorporating R and Python. But enough of me talking, let's head on over into R and I'll show you what's up. So before we get started, you can find full access to the code and associated documents, including a Power BI file for you in one of the links in the description below. Will bring you to GitHub where this is published in a repository called R for Power BI. So in this document, essentially what we're doing is we're going to load some beer data, and more specifically some beer rating data that I think is kind of interesting. And so we will be running that in, and let's say that this is the most important data in the world that warrants having an entire Power BI dashboard built just for it. What we're going to start by doing is running our packages. So you'll see in the code here that there are a lot of notes. If you download the full data, you can read those and sort of use this as a working guide for you. But essentially what we'll do is we'll run the packages to start. And what I do here is I also suppress the warnings. This will just kind of save us some time down the road from having to sift through additional text, or we don't want to scare Power BI. We have to be very gentle with it, basically, when we're using coding software. So all of our code needs to be extremely clean, organized, and well commented, so that way somebody else down the road that may not be familiar with R will still be able to kind of understand what's going on if they see an R language in Power BI. So we run the packages here, we suppress the warnings, and then we removed this package object that I used to load the packages. And then getting data in a .dta format is a little bit difficult. Essentially what you would have to do is set the working directory to where the data is located. And this will help Power BI be able to locate that data initially. And so what I do is I do the read_dta with the file here being beer.dta, and then read in that data as a data frame. Note that when you read in data into Power BI, it has to be as a data frame. I haven't tried using tables or matrices, but I was reading online that it essentially has to be a data frame. I'm not sure if that's an old feature or not, but that's okay for this project. We can run it with a data frame. So we'll run this, and then we have our beer data. Let's go ahead and take a look at this, and I'll sort of show you what we're working with here. These are essentially ratings of beer, where a rating of 1 is of high quality, a rating of 2 is sort of medium or good quality, and a rating of 3 is pretty poor or fair quality. And we got every beer under the sun here, a total of 35. So I guess not really. I'm not very much of a beer connoisseur myself, but we got a lot of German and European names in here, so I'm assuming that these are the creme de la creme of beers. But we got a lot of data here. Most of it we probably won't use for the report. We do have like alcohol content, its overall price, if it's US made or not. And then we have 3 different variables for rating. We have the quality, which 1 is fair, 2 is good, 3 is very good, similar to the rating on the first column. Then we also have this good and very good, which is just a dichotomous variable to indicate those two kinds. But let's say that when we're going through our data cleaning practice, we don't really need all of those variables. What we'll do is we'll first rename some of the variables here. So avail will be made regional because it's 1 if it's a regional beer, 0 if it's available throughout the nation. So just making things a little bit more intuitive there. And then also US made instead of just US. So that way we actually know that it's manufactured within the US. We'll kind of make our data a little bit more readable down the road. And then, like I was saying, we'll remove some of the variables. And then I noticed that Guinness and Keystone Light are not in the data set. And this kind of upset me, so I decided to add 2 rows of data there as the 36th and 37th row, as Guinness with all of the information that I found online for Guinness, and Keystone Light for all of the information I found online for Keystone Light. Doing this in Power BI would be a little bit annoying. It's certainly possible with things like DAX and other languages, but this is something that's really, really easy with R, so it kind of makes a good example for why we'd use R in loading this initial data set. So I ran that, and then what we do after this is we want to do some sort of analysis. R is sort of the king at doing statistical analysis, and so what we've done here is we've made a function that will sort of flatten or make into a more data set readable correlation matrix, where it's sort of like a network matrix, like an edge list, where you have the relationship between the 2 variables, its correlation value, and then its p-value or p-score. So we create a function to do that for us, and then we run 2 variables here, rcore, which will give us that correlational data, and then also the flattened correlation matrix function that we built up above. So we used the library HMISC. I don't know how to pronounce that. HMISC, I suppose we'll call it that. We used that library to help us out. And then finally, we're creating a graph, which this graph is going to ultimately be used in Power BI. So great. So we have the data, you know a little bit about it. We've done some data cleaning. Let's hop on over into Power BI and see how we're going to get all this connected. What we want to do in Power BI is pull in the data, see how we might be able to make some changes in the data using R, and then also how do we add in these R graphs into Power BI once we're all done. So what I've loaded up here, and you'll see the file here, I have all the files in one folder because I'm very organized and my files are not, all throughout my desktop. But I have the data, our package, our project, any sort of GitHub related version control, and then also the Power BI file. So I opened this in advance, and this is just a blank Power BI file. What I'll do is to get data, I clicked on File on the top left, and Get Data. And this sort of interface will pop up for you automatically if you open Power BI off the start. It will sort of force you to pick a data source. And one of the data sources that most people don't know about is R. So I'll type in R in the top here and search for that. And then if I scroll down just a little bit here, since R is only one letter, we'll find nearly everything. But essentially, here's an R script, and here's a Python script. So we will open R script. And so we can pull in data if our R script isn't going to take longer than like 30 minutes to load. I'm pretty sure that's the timeout period for Power BI. Also, our R script isn't going to prompt us to fill in any API information or any security checks or anything like that. So we're able to just paste in our R code here. And we can really just be pretty rough with this, and we'll just grab everything above the plot. We don't really want to include the plot there. And yeah, we'll include most of the comments. No need to really review that because when we coded it the first time, it was pretty clean. We suppressed some of the warnings. We didn't sort of overpopulate with tables. We used RM, the function RM, to remove any leftover data. So this is just a really clean file. So we hit OK on that, and it will run through that working directory, pull out the data, and then recognize that we did some statistical analysis and made another data frame. And so now we're able to pull in these additional data frames into Power BI. So I'm going to select that I want both of these. But actually, I noticed that when I went in to beer data, that we're going to have an issue down the road. This rating variable is rated 1 if it's a really, really good beer, which Guinness is, and 3 if it's really, really bad, which Keystone Light is. And then 2 is kind of in the middle. But people aren't going to know that if they visit our dashboard sort of just natively. We're going to have to swap out those values. So let's go ahead and transform the data. So let's say that we didn't catch that. So now we are in the Power Query editor for Power BI. If you're familiar with Excel, you may be familiar with Power Query editor as well. We'll go ahead and click on the beer data. And we see that, yeah, we have a numeric variable for rating, but this is really probably better fit as a category variable, and we want to rename those. So we have two options. We could go to transform and run an additional R script. This will open up an additional R script on top of everything else, and then run the data basically all over again, run the code from start to finish. Or what we can do is just edit the source code and make those changes back at the start. So this will, I clicked on the cogwheel on our source, so this opened up our fully commented code with contact information, everything good to go. And what we'll do is we'll fix that, and I will code this live. So let's say that we want, we'll make a function, and we'll call this function x. Now we'll call it rating, because we're being good coders and we're going to make everything really intuitive. And I'll make a comment here that we want to swap out the numbers for something more intuitive. And so I'll make a function. There's probably a better way to do this than the way I'm doing it. Let me know in the comments below if there's a better way. But this is just the way that I enjoy doing things. So I'll do a function x, which is if x is logically equal, so what the double equal signs are, logically equal to 1, then that was our, we're going to return, that's our best beer. And then close those brackets. That's the thing that's annoying about coding this directly in here, is that it won't autocomplete your code or make suggestions or errors. It really is just a text interface. But else if it's 2, we don't need to quote those because remember it's a numeric variable. So else if it's 2, then what was 2? We'll call it good, so it's not as good as best, but it's still good. And then need to remember to close the bracket, and then all other values are just going to be, we'll return a, we'll call it fair beer. And close that, and then don't forget to close it again. Cool, but we're not done. So we got a function here that basically is going to select the different kinds of ratings that it has currently, 1, 2, and 3, or 1, 2, and all other values, and it will give us our ratings properly. And so now what we can do is we can do beer DTA rating and then just swap this out with a sapply, which will sort of list-wise go down and apply our function that we just made. So we want to do our, then what did I call the function, rating. Cool. So now we have a function that's going to clean this up, and then I'll put a comment here that said this list apply. I know L applies technically list apply, but S apply is the same thing. List apply helps us use the function. Great. So then I hit OK, and it doesn't break, and we should be good. And I'll show you why I coded that live here in a second. So now it's going to run through all of that again, pull in the data. We'll do the navigation step below it, and we see that the variable swapped out. Great. So this is going to be way more intuitive to help us out. If we do try to code things after the fact, let's say we pulled in the data from like SQL Server or Snowflake or someplace else, we can add a R script here. But you'll see this comment, and you'll see this comment as well when you make a graph. But what this is it's saying that the overall data set, the beer.dta, it swapped that out with data set. So if you wanted to code something, instead of beer.dta or whatever your data set is, like df, it's going to have to be data set $, whatever you're working with. And that can get kind of annoying, and you can run into some errors with that where you'll return a blank table. So I've always found that it's best to just go back to the source and make those changes. So great, we're all good here. We caught that change and we were able to make it live here in Power BI. Let us close and apply it. And then what we'll see once this loads in, and I'm pretty sure that our scripts are going to run faster than what Power BI does. That's just kind of a hunch, depending on your R script, and also is going to allow you to micro benchmark different parts of your code. Probably a little bit easier than what Power BI does as well, because the Power BI interface for checking load times on different graphs doesn't really hit the actual data source and data calculations as well as I would like it to. So micro benchmarking our code is going to be a little bit easier. But great, so we see that our data pulled in, beer DTA, and also our correlation data, which is super cool. So we can now record some of our statistical analyses without really having to add in new measures, quick measures, combine those measures, create sort of groups, and do all that fancy Power BI stuff because we know R already. So with that in mind, now what we want to do is insert a graph. So what we would do is we have Python and R right here. So let's just click on an R graph. And what we want to do is use some of this correlation data. And so here we need to enable our graphs. It's going to ask us this probably a million times, but just click enable every time it comes up. And let's just make this big and right in the upper corner. And one thing that I'll mention before I forget is to enable having R on your platform at all, just go into your settings. You probably have this already enabled, but if you go into options and settings in the drop-down menu and click on options, you actually have an area to select the R script and Python script to use. So here I have my R program identified, and I use the IDE RStudio. Same thing for Python, I use Anaconda 3, but you can swap to Python 37 or wherever you wish. And so that's how you would do that if you're running into that issue. But here we have our graph, and we really want to insert an R graph because we did all this statistical analysis, and maybe in R we've already done some of these graphs. And it turns out we have. So what we have here is we have a correlation plot. So if I run this, we can see that we have this super cool correlation plot, which is plotting the number of how correlated two variables are. So we see that price and cost are very highly correlated, and that having a light beer is very correlated, or conversely correlated with having a lot of calories. These are things that make a lot of sense. And then what I've done is I've removed insignificant values. So insignificant values are left invisible here with a significance value of 0.01. And honestly, I have no idea how I'd make something like this in Power BI. I'm sure it's possible, but since we know R, we can just plop in this code and get it set up. And so instead of coding it time, I'm going to save some time by just copying these comments here. And you can find all the comments to this in the GitHub repository in the description. But I will go in here, and then notice that it wants you to select all the values. And what we really want for this graph is to use all the data. So we don't really want one variable. So what we need to do is we need to add in all the values here that we're looking to use. So we're looking to add not the beer label, but what we want to do is add in, unselect that, all the numeric stuff that we got here. And I'll leave out US made because I don't think I included that here. Yeah, no, but I will show that here in a second. So we got pretty much our entire data set here. We got a little green check mark or a yellow check mark there saying that we're good to go. And we get some boilerplate comments whenever we're starting to work on in a graph. And what it includes is saying, hey, this is how we redefined your data set when they pulled in the data, so it's no longer beer.dta or beer space DTA. It's now called data set. And you really have to keep that in mind, that this is a data frame of all the variables you just selected redefined as data set. So when you do the script, you will have to do something like this. Let me uncomment this real fast. And there we go. So this is what you would have to do. And note that you can put in comments here on your graph, which is really cool. but you will set up the packages that you're using, which again, we're using HMISC and correlation plot or core plot, which is what I use to build this graph. And essentially core plot is redefining the data set. So I just put in data set, not beer.dta, as a matrix, and then put that into a new object. And then when I built this, I was able to use that object as a reference from there on out. So just swapping out the data set in one location and then using this new object throughout everything else. So make sure to have something like this at the top of your graphs, just to make things a little bit easier, so you can kind of keep the same language or same nomenclature that you were using before. So now you got all this. It's saying that duplicate rows will be removed from the data. No problem at all. Let's go ahead and run it with that button there. And we'll see that our graph populated. Great. So now we have our graph here. But let's say, oh man, you know what? I really wanted to include a little bit more into the data frame. And I forgot this US made variable. Let me click on this. And see, I clicked on it, and it's going to have to reload for a second here, but it'll add that in. And then I'm looking at this, and I'm like, well, you know what? It's not really helping me out too much knowing that it's US made. Let me just remove it. And then we can go ahead and remove that. So there's a little bit of interactivity with limiting and expanding the scope of the variables allowed in the graph. But that said, you know, after we have this here on our main page, let me close this. We have this, which is cool and all, but every time we click on it, we're going to see this giant script pop up. And also, you'll note that the graph is very static. It's not interactive. So if we include a graph next to it that's very interactive, audiences might assume that this is also interactive, and they'll try to start clicking around and stuff. So what I've done with R in the past is I will have sort of static statistical reports on one page that sort of read like a PDF or PowerPoint slide, and sort of have that overall look and feel. And then on another page, I'll have neat interactivity, sort of buttons and all that stuff. What you can do as well in Power BI to make things more interactive is integrate some HTML into your R coding, and that will make things interactive. But I don't think that things like R Shiny are going to make your graphs more interactive. A last option is to have buttons and sort of overlays on top of your graph. So nobody's ever actually clicking your graph. They're clicking on invisible buttons on top. And then those buttons can route to appropriate changes on your graph. And that's kind of a neat little workaround to get around interactivity. I'll link some videos in the description to help you out with figuring out stuff like that. But overall, that's essentially how you would pull in data from R, how you would make data changes in R, or in Power BI using R, and then that's how you would create new graphs using R as well. I hope you've learned a lot. Feel free to let me know if there's any better ways or better practices or things that you've learned in the description. And yeah, thanks for watching.